Here's integrated 3. It's problem 2-96. It says, what is the distance from the point 4, 5 to the line y equals 2x plus 3? So I want to know the distance from this line to this point. And so we started this in class. There we go. And I think we had at least, now you don't have to graph these, but I'm going to graph it for you because I think it helps you understand the concept of what's happening. So y equals 2x plus 3. The y-intercept's at 3, so I made a dot at 1, 2, 3. The slope is 2, so I'm going to go up 2 over 1, up 2 over 1, 2. And you could do the problem without drawing the graph. It didn't ask you to graph it, but having the graph will help you understand what it is you're trying to find out. You're trying to find the distance between this point, 4, 5, and this line. Okay, so how far is it? Well, I'm not going to measure like from here to here, or from here, like if I have a ruler, I'm not going to measure it like that. I'm going to try to measure it in a perpendicular way, but how can I know exactly what is perpendicular? I mean, I can kind of try to line it up, but that's not really the way to do it. We want to do it with algebra. I am going to sketch what seems to be a perpendicular line, and I'll just sketch it, and I'll call it the yellow line. I mean, it might not be perfect, but anyway, so this right here, if I had this point, if I knew what the ordered pair was for that point, and I don't, you can see it didn't seem to land on any grid lines. But if I did know it, then I would use the distance formula. Like I would call this, now I can call it x1, y1, 2, y2. And when we were in class, somebody told me that they knew what the distance formula was, and they recited it to me, and it went like this. The distance formula, it's the difference between the x's squared and the difference between the y's squared. It doesn't matter which order you put it in. I think I'm going to put the like this. I think I'll do y2, y1, x2, x1. Okay, that's the distance formula. That, if I had the numbers to plug in here, if I knew what those two numbers were, I'd just plug them in here and I'd have my answer. I would know how far this is right here. Okay, so how can I find out what the ordered pair is? I need to find, I already have the equation of this line. This line is y equals 2x plus 3. I need the equation of the yellow line. The yellow line is going to have a slope that is perpendicular to the existing line. So we know that we can do that like this. X plus b. We did this part in class, and it got a little messy. We know we can use the perpendicular slope is going to be the opposite reciprocal. So we're going to have, and then we don't know what b is. It looks like it's up here somewhere. So we'll find it by plugging in an x and a y. The only x and y that we have is the 4, 5, and it does happen to be on our yellow line, which is the perpendicular line. So that's a y number, so I'll put that in for y. And then the x is 4. And then negative half times 4, I think that's negative 2. Add 2 to both sides, and b is equal to 7. So now I know that the equation of this line is y equals negative 1/2 x plus 7. Okay, So I have two lines, and they cross right there. I have the equation of both of the lines, so I need to find out where they intersect, and we learned last year, or maybe in Integrated 1, that lines will intersect, like we can use the equal values method. So I'm going to set, or you can think of it as substitution. I'm going to set them equal to each other. So I'm going to go 2x plus 3 is equal to negative 1/2 x plus 7. And I'm just going to solve for x. Get all my x's together. I'll add half x to both sides. Maybe I'll minus 3. And then that'll give me 2.5. Well, I'll call it 2.5. Four. And I'll just use a calculator because I have a feeling we're going to have, before this is all over, there's going to be decimals in our math. So 4 divided by 2.5. 1.6. So now I know that this is 1.6. That's my x value. How can I get my y value? If I just had the y value, I can plug everything in here and be done with this. So the y value, I can plug my x into one of the equations, it doesn't matter which, and find out what y is. So I'll use this one because it doesn't have that negative fraction in it. So let's go y equals 2 times 1.6 plus 3. What is 2 times 1.6? Oh, I just had it on my calculator. Oh, 3.2. I should 3.2 plus 3. So if I add that, that'll be 6.2. So now I know that y is 6.2. So now I have 2 points. I have my x1s, my y1s, or whatever. So it says y2 minus y1 squared. So I think I'm going to carry this on down here. There's not enough room up there. y2, which is 5, minus y1, which is 6.2, squared, plus the x's. So x2 is 4, and x1 is 1.6. And then I can just do all this math. Oh, did I do it right? I guess it wouldn't matter if I find the differences, huh? Let's see if this works out right. This one's 5.76. So it took me a whole sheet of paper to do this. Even if you didn't like draw the picture of the graph, I would still expect your work to. I don't think you'd be able to get the equation of this line just in your head. You'd have to write something down for this. So I wanted to see maybe not the graph if you don't want to, but I wanted to see how you got this perpendicular line, and I wanted to see the system of equations because I don't think it's obvious. I don't think you could just do that system of equations, you know, the equal values method in your head. And then I see how you would maybe just put all that in your calculator. You just put all that, like type it right into your calculator and get the answer out. But some of you didn't show enough work, and some of you showed some very interesting work, which I would like to know where it came from. But anyway, there's 2-9.